Let's take a look at this limit here as x approaches 3 of this expression. As always, we want to try to evaluate by simply plugging in directly x equal 3. Of course, what happens up top, 3 minus 3 is 0. Down on the bottom, I get the square root of 3, and then 6 minus 3 is 3. So I get the square root of 3 minus the square root of 3, which is 0. And so we get the indeterminate form, 0 divided by 0. And this requires some work then to find the value of the limit. Well, I see in my denominator that I have these radical expressions, and so you should be reminded of the technique of rationalizing, in this case, the denominator. And we're going to do that with the conjugate. So if you remember, the conjugate of that denominator would be the square root of x plus the square root of 6 minus x. Of course, what I do to the denominator, I must do to the numerator as well, so that I am in effect multiplying by a grand total of 1. So let's multiply this out. Now up top, I'm going to leave it factored. So x minus 3, remember there's a parentheses around this x minus 3. So I want to make sure I have a parentheses around that x minus 3. And then this stuff here needs a parentheses around it as well. I do not want to, FOIL this out, expand this out, leave it factored. On the bottom, we do want to FOIL that thing out, right? So I've got this expression times this expression. So just do the FOIL technique, if you will, first, outer, inner, last. First times first, what's the square root of x times the square root of x? Square root of x times square root of x is just x. There's the first. Now the outer would be the square root of x times the square root of 6 minus x. But notice the inner is negative the square root of x times the square root of 6 minus x. So what's going to happen to that outer and inner term? Those outer and inner terms are going to add to 0. And that's the whole point of the conjugate, right? When I multiply by the conjugate, the outer and inner terms, which will have radicals, right? Square root of x times the square root of 6 minus x, those will equal 0. So I'm not even going to write those down here, but the outer plus the inner is 0. So now I go to last. Negative, be careful, negative times positive is going to be negative. And what's the square root of 6 minus x times the square root of 6 minus x? Well, that's just 6 minus x, but please be careful to put that in parentheses because this negative sign needs to be distributed through that. Okay, so again, when I do the square root of, a times the square root of a, I get a, and that's what I'm using to get this result down here. Well, if I simplify, if I distribute this negative sign through down here, then what am I going to get down there? Of course, up top, I still have the same expression. But now below, I'm going to get x minus a negative x. X minus a negative x is x plus x. X plus x is 2x and minus 6. Okay. Well, we see it, I think, right? If I go ahead and factor out the 2 from the denominator, we'll do that real quick. So rewrite everything one more time. Nothing going on up top, just leaving it the same in its factored form, which we want. Down below, I factor out the 2, leaves me x minus 3, and there it is. I knew right away when I plugged in x equal 3, eventually I'm going to get down to a point where I have that common factor of x minus 3. So I can divide numerator and denominator by x minus 3. So when I do that, I'm now looking at the limit as x approaches 3. Now I can just write up top the square root of x plus the square root of 6 minus x. And it's in parentheses, but I don't need it anymore because I'm multiplying by 1. And the bottom just has 2. And now I can plug in directly and get the value of the limit. When I plug in directly, I get the square root of 3 up top, plus 6 minus 3 is 3, the square root of 3, all divided by 2. Well, the square root of 3 plus the square root of 3 is 2 times the square root of 3. And then simplifying, I get the square root of 3. And that's the value of the limit. Keep in mind, you can always check your work numerically. So I can go back to this original limit up here, put that, say, in the calculator, do a table of values, and what's this value approaching as we get close to 3, plug in 2.9, 2.99, and so on. Now, in this case, the square root of 3 is not a nice number, right? It's like 1.7 blah, 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 right? It's an irrational number. So, but at any rate, you could check and sort of see, does that seem like we've done it correctly? Okay, so again, look at the support. Notice the limit signs have to be written out each time until you plug in. Then you don't need the limit sign anymore when you're evaluating it. Without the limit sign, it is incorrect. Okay, hope this helps on this one.